Introduction to probability theory. During the discussion of probability theory, mathematical probability theory in statistics or in computer science, one of the most important terms is random experiments. Random experiments, random experiments, the phrase, the word random is used because it has more than one possible outcomes or results. If it is not more than one possible outcomes, it will be called deterministic experiment. But uh, in most cases are more than one possible outcome, so we call it random experiments. The word the word random is used because more than one possible outcomes. And experiments, uh, the phrase uh, is experiment plus multiple possible outcomes. So when a experiment has multiple possible multiple possible outcomes, then it is called uh, experiments. So random experiments are the experiments where more than one possible outcomes and multiple possible outcomes. These two terms will be uh, combined. What is outcomes? Outcomes is a possible result of the random experiment or trial. What is the relation between random experiment and sample space? Now, all possible outcomes as a sum is called sample space. And random, the word this is because probability theory is based on the assumption that an experiment is repeated and can be repeated several times under the same conditions. For thus, it is random. The random experiment is a procedure defined on well-defined set. Event. Event is a set of outcomes or set of possible outcomes. Event is a subset of sample space. If we will define the sample space as a set, a sample space is a complete in such means it is a total set of possible outcomes. An event is a possible outcome of an experiment or forms a subset of the sample space. The sample space can be defined as the list of all possible outcomes of a random experiment. Trial, sometimes it is trial or experiment. The same word, sometimes it is occur. When a random experiment is repeated many times, each one is known as a trial or experiment. The random experiment, event, trial, sample space, and outcomes, we want to connect with the examples. There is a very common example sometimes is used in the books that are Bernoulli trial is a random experiments. But we were going to a example which is very common to us and is very familiar to us. Example, random experiment is a tossing a single coin is a random experiment. Before tossing a coin, you don't know about the result. So this is an example of a random experiment. In particular, a random experiment is a process by which observe something uncertain. After the experiment, the result of the random experiment is known and outcome is a result of random experiment. The set of all possible outcomes is called a sample space. Thus, we can say that the random experiment, the sample space is our universal set. Example of random experiment: toss a coin, roll a die, and observe the number of iPhone sold by an iPhone store uh, in Germany in 2022. It can be shown by experiment, and its outcome can be expressed as a sample space. But we are going to a very easy example. This is tossing a single coin. Tossing a single coin. In a coin, one side is said to be head and other side is said to be tail. It is chosen as you wish. Then the sample space is the set where head and tail. The only two possibility, head and tail, because it is unbiased. Head and tail, these two outcomes are called sample space. This is a universal set in the context of the set theory. And outcomes are the possible results, head and tail. These two are outcomes. And events are the set of the sample space. It can be assumed as a power set. I cannot say it's a power set because I cannot assume that phi is an event at here. Means I want to say that in our discussion we cannot assume events phi is uh, event. Here events is only head, only tail, head and tail. It's an events. Uh, Event is the set of sample space, is a subset of the sample space, and suppose event is like this, express as a set where only one head. This is expressed as the sample space only one tail. This is and expressed as the result of the sample space head and tail, like this. Now we will going to I will be going to discuss of tossing two coins. It will be more clear and more accurate because this is expressed as largely. Tossing two coins. What will be the sample space? If two coins tossing at same time, it the possible outcome: first coin is head, second coin is head, first coin is head, second coin is tail, first coin is tail, second coin is head, and both coin will be tail. If we will toss two coin at same time, outcomes are each of the elements of the sample space. Both head, first one head, second one tail, first one tail, second one head, both tail. These are the outcomes. The possible outcomes or possible results are mostly used the term. Events actually, in fact, it is a power set of a sample space. For instance, the event space at least one of the coins is head is shown by a set E event is equal to head 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 tail tail head. It is a subset of the sample space. It is assumed as a case that is occurred at here that the event is construct at that at least one of the coin is head. It is an event and it will be expressed as a set and it must be a subset of a sample space. Uh, how many possible outcomes outcomes uh, how many possible outcomes. It may be a finite or infinite, depends on the case, and related to the sample space, it can be defined the total outcomes, and what will be the event, and for the case of the events, how many possible events are shown. It will be 2 to the power number of outcomes, because it is a power set, and pi is included. This will be the total events, and events are the subset of the sample space. So each cases um, can be formed, and the total number of the events is fixed. Next, we will going to discuss another important things. This is probability functions. Assign each events in the event space a probability using the number between 0 and 1. In mathematical probability theory, uh, it is well defined, and we can uh, define it by a number 0 and 1, and between 0 and 1, 0 is the impossibility of the outcome, and 1 is defined is certainty. To define the probability function, there are a lot of types of constructions. It may be a discrete functions, and it may be a continuous functions, and so overall it will be shown that probability continuous function, probability discrete functions, probability mass function, uh, PMF, probability mass function, and CDF, continuous density functions. There are lots of types of probability functions are defined. Here I am trying to express a general form of the functions, of where x is the random variables, the variables of mm, uh, random experiments, and x is the values. These values is maybe any set of numbers. Here used natural numbers. A function small p capital X of variable small x is equal to probability capital X is equal to x. Probability is defined at here. Here I uh, mm, an example. Suppose x is equal to 1 2 3 4 total of its here, and frequency is 10, means the fact of happening of the case 1 is 10 times, case 2 is 20 times, and 3 is 30 times, 4 is 50 times, and the total of the frequencies is 100. We can now going to estimate of px of x, where here capital X with respect capital X random variables, and variable is small x values. Same 1 2 3 4 happening of the case of 1 is estimate of px is probability 0.1. It is a 10 out of 100, and happening of the case 2 is probability is 20 out of 100 is zero point 0.2. It is 20 by 100, and 3 similarly 0.3, and 4 similarly 0.5, and the sum of the estimations of a small p x of x is equal to 1. It is unbiased, and probability of the random variable x of values 1 case 1 the probability is 0 0.1, and probability of random variable x is equal to 2, case happening 2 is the probability 0 0.2, and probability of x uh, is equal to the values of small x 3, happening of the case of the 3 probability is zero point 0.3, and happening of the case of the values 4 of the probability is 0 0.5. And the main thing we want to discuss as a sum of it at here is the probability pace. Probability pace is a discussion. Uh, it is a combined of a constructions where omega is the sample pace and f is the event pace, a set of all events f, and p is the probability function, and it is defined as a first bracket. This is called a probability pace, and it is a mathematical construction, and probability pace is a model of the process of random experiment. And and the probability pace provide a formal model of uh, a random process or experiment. The mathematical triplet omega f p that presents a model for a particular class of real world situations. And I want to discuss another thing. This is closely related to measure theory. This F is a collection of all the events you'd like to consider as a sigma algebra. And this event, uh, where P is termed as a set function, this will be the probability measure. And probability measure will be defined. P is the function from the set F to the set close interval 0, 1. And probability theory, uh, in discussions of the measure theory, uh, is the finite cases only. And the when the case will be the large or infinite cases events, then it will be more comfortable to construct these things with a measure theory. And probability mass functions p will be defined at this place. And I want to say in this case that which is the relations with the measure theory and probability theory. It has a connections between it, and we will discuss this later with more precisely, and our upcoming lectures will be enriched on these topics.